Okay, one thing I want to revisit, I want to talk about when we are adding and subtracting and combining like terms. For example, when we've had problems like x squared plus 4x minus 2, can we put those things together? Even though there's x's right here? No, you can't, because they have to be, you have to put together x squareds and x's and so on. So like if I had 2x squared minus 4x minus 2 plus 2x squared plus 7x. Can we simplify from here? Yes, you can go through and you put the x squareds together. How many x squareds is that? 2x squared and 2x squared, 4x squared, and then you have minus 4x plus 7x, which gives you 3x, and then you have just the minus 2. This is a simplified version. You have to have the same thing with it, like the x squareds, to be able to put it together. So it's the same when we're dealing with the radicals. Before we can put things together, we have to make sure that what's underneath the square root sign is the same. And you want to make sure that it is in simplest terms before we start. Right here, 7 is underneath the square root sign. Is 7 prime? 7 is prime. That's the lowest we can get it. Prime, remember, means that the only numbers that multiply to get that number are 1 and itself, right? 1 is prime, 3, 5, 7. 9 is not, because you have 3 times 3. 11, 13. It would have to skip up to 17. 16 is not, because 4 times 4. 18 is not. 19 is. 20 and 21 is not. 22 is not. 23. All these numbers, what they have in common is you can only do multiply 1 times itself. That's what prime means. Okay? So, now this is saying 3 square roots of 7 plus 5 square roots of 7. How many square roots of 7 do we have? 3 plus 5 is 8 square root of 7. That's the answer. Okay? Now let's, yes ma'am. 2 is prime, my bad. Were you still back on that one? 2 is prime. Sorry. There we go. All right. Right here, square root of 5. 5 is prime. That's as low as it can go. I have 10 square roots of 5 minus, remember this is a 1 square root of 5. So 10 minus 1 is 9 square root of 5. That's your answer. Now, if we look at number 3, 2 is prime and 3 is prime. But they're not the same, are they? It's like an x squared and an x. So your answer just stays 4 square root of 2 plus 6 square root of 3. You can't put them together. That's like you can't add together an x squared and an x. Those of you, oh no, I guess we need to do some other things. All right, number 4. All right. Let's do this. Number 4. These are not in simplest form. They are not reduced. So let's start and do number 28. 28 reduces to, what is that, 7 times 4? Okay. Now, I can reduce this down. Well, I'll keep going. I'll go 2 and 2. This is the square root of 7 times 2 times 2. How do you know what gets to go outside of the square root sign? A pair, right? You have to have a partner to go outside. So I have 2 square root of 7. That's the first one. Plus 63 splits up as 9 times 7. 9 splits up as 3 and 3. So I have 3 times 3 times 7. Who gets to go outside? The 3's do. So it is 3 square root of 7. Now, are the square roots the same? Yes. I have 2 square roots of 7 and 3 square roots of 7. 2 plus 3 is 5. So my answer is 5 square root of 7. Just to that, yes, you're simplifying like that. Right now, try and do number 5. So we need to simplify 45 and then put them together. Okay, so I want you to try and do number 5 and 6. On number 5, we're going to reduce and split up 45. That becomes 9 times 5. Now from here, if you already see perfect squares, 9 is a perfect square. What is the square root of 9? It's 3. So I know this becomes 3 square root of 5. If you start seeing your perfect squares, you can do it this way. Minus, now this is already in simplest form, 2 square root of 5. So now we do, these are the same. So now we do 3 minus 2. So you get 1. You can write 1 square root of 5, but really a better way to write it is just a square root of 5. The next one, square root of 6 is as simple as it can get. They're both square root of 6. So all you have to do is take 3 minus 8. You get negative 5 square root of 6. That's your answer. It's negative because it says 3 minus 8. 3 minus 8 is negative 5. Here are the next ones. Reduce them and then put them together. On number 7, 7 is underneath the square root sign, 7 is as low as it can go, so I need to change 28. 28 is 4 times 7. Now, you can continue going down to lowest terms. I know that 4 is a perfect square. The square root of 4 is 2. So I'm going to rewrite this. I've got 5 square root of 7. The square root of 4 is perfect square, so it's 2 square root of 7. Okay? They're both square root of 7, so I have 5 plus 2. My answer becomes 7 square root of 7. That's my answer. All right, on number 8, neither one of these is in simplest form. 48. 4 times 12. Okay. 12 is 4 times 3. I know that these are perfect squares, right? So if I rewrite, the 2 is already out front. Now, the square root of 4 is 2. Square root of 4 is 2. That takes care of these. Now, again, you could still be writing these underneath the square root sign. 2 times 2 times 2 times 2 times 3. And doing the groups of 2. You can do that. What's left is the 3. That goes there. So 2 times 2 is 4. 4 times 2 is 8. I get 8 square root of 3 for the first one. Minus, now I have to do 27. 27 breaks up as 9 times 3. 9 is a perfect square. The square root of 9 is 3. So I get 3 square root of 3. Now they're both the same. The square roots are. Now I can subtract. I have 8 minus 3, which is 5 square root of 3. That's my answer. Number 9. Square root of 3 is as low as it can go. So I need to separate 75. 75 goes 25 times 3. I did 25 because I know 25 is a perfect square. What is the square root of 25? 5. So the first one stays as 8 square root of 3 plus square root of 25 is 5. The 3 still is in there, square root of 3. 8 plus 5, 13, square root of 3 is the answer to number 9. Let's flip over to a second to number 20. It says find the perimeter of an object, of each object. What does perimeter tell you? What are you supposed to do with perimeter? Yeah, add all sides. Well, if this top side is 5 square root of 7, so is the bottom. If this is 3 square root of 7, so is the other side. Now, they're all square roots of 7, so I just need to add 5 plus 5 is 10. 13, that's 16. So my answer becomes 16 square root of 7. All you're doing is adding up the sides. Number 21. Well, why is that all the way up there? Let's see here. There we go. Number 21. We need to add up all the sides. I know that if this 5 is in lowest terms right here, square root of 5. So I know this side is 4 square root of 5. Let's reduce and fix 3 square root of 45 because 45 isn't in simplest terms. 45 can split up into 9 times 5. There's my perfect square right there. So I already had a 3 outside. What's the square root of 9? 3. So the 3 goes outside and the 5 is left inside. 3 times 3, 9 square root of 5. So instead of this, I'm going to write 9 square root of 5. And that means down here is 9 square root of 5. So now I have 9 plus 9 plus 4 plus 4. What is that? 18 and 8, 26. 26 square root of 5. Okay, we'll come back to the other ones in a minute. There we go. Let's take a minute and I want you to try and do 10 through 12, please. Okay, first off on the first one, square root of 10. Can you simplify that any farther? It breaks up into 2 and 5, so you can't do anything with that. But 40 breaks up as 4 and 10. Square root of 4 is 2. So first off, this one is 8 square root of 10. It stays like that. Plus, now, this one, 2 square root of 40. Well, the 10 stays inside there. The 2 comes out here. So 2 times 2 is 4 square root of 10. I have 8 and 4, which is 12 square root of 10. That's your answer. 11 should be easy. It has square root of 15, square root of 15. So this is 13 minus 11. 2 square root of 15. That's your answer. Now, number 12. 12 is not in the square root of 12 is not in simplest form. If I break it up, I've got 4 and 3. Right? Perfect square right here. So I get 2 square root of, well, The square root of 4 is 2. That goes out there. The 3 gets left behind. 2 times 2 is 4. Square root of 3. That's what it reduces to. Now we need to reduce this one. 27 breaks up as 9 times 3. The square root of 9 is 3. So I have 6. Let's see, square root. The square root of 9 is 3. That goes here. And this 3 gets left behind. So it's going to become 18 square root of 3. When you add these together, 4 plus 8, 22 square root of 3. Next ones, 13 through 15. You should try those now. Thirteen's really simple because why? They're already, the 8s are already there. Well, but you know what? Actually, we can do this. So we can go and do 6 minus 3 and get 3 the square root of 8. But 8's not in simplest form. 8 can split up into 4 and 2. The square root of 4 is 2, so I have to bring a 2 out. So I'm going to have 3 times 2 square root of 2. Your answer should have been 6 square root of 2. I have a feeling that if you did it, you left it as 3 square root of 8. Be very careful. You have to have it in the simplest form. Number 6. Did I leave it on square root of 8? No. Okay. 6, like right here on this one, 6 is as simple as it can go because 6 can only split up into 2 and 3. There's no doubles there. Okay, so 6 is one of those that stays, square root of 6 will be as low as it can go. So you'll have 3 minus 8, and you'll get negative 5 square root of 6. A repeated question again. Now, number 15, square root of 2, that's as simple as it can get, so let's look at 50. 50 can split into 25 and 2. What's the square root of 25? 5. So this becomes 9 square root of 2 minus 5 square root of 2. 9 minus 5, 4 square root of 2. That's your answer. Number 16 through 18. 16 through 18. Do those now. All right, number 16. 3 is as simple as it can go. 12 will split up, though, as 4 and 3. Square root of 4 is 2. So the first one stays 4 square root of 3. Square root of 4 is 2, so I have minus 2 square root of 3. Okay, whenever I'm starting to look, I'm trying to simplify it so that they're the same. Now I have 4 minus 2, which is 2. Well, bad 2. Try again. 2 square root of 3 is your answer. 32. 32, you can do it all into the individualized prime numbers. I know, though, I'm looking for some perfect squares. I'm going to start thinking about that, and I know that I've got 16 times 2. What is the square root of 16? 4. That's why I'm trying to figure those out. So I've got 4 square root of 2. That's the first one. Now 72. 72 for me on this one. I know 9 times 8 is 72. 9's a perfect square. So I've got the square root of 9, which is 3. 8 breaks up into 4 and 2. Square root of 4 is 2. So I'll take 3 times 2 and get 6. So I'm going to have minus 6 the square root of 2. Now to simplify, 4 minus 6, negative 2, square root of 2. Now, number 18 says b to the fourth, b to the fourth, right? So they're saying 4 plus 7 is 11 square root of b to the fourth. But this is not in lowest terms. I want you to think about this. B to the fourth means 1, 2, 3, 4. What's the rule to get out of the house? Have a pair. There's a pair. There's a pair. Right? So the answer becomes 11b squared. Now, we did these. Now we're to here. We're again finding perimeter. Means we're trying to add up all the sides. I know that I can add these two together. Why? They have the same square root of 2. So how many of those do I have? 14 square root of 2. I need to simplify this one. So 8 splits up into 4 and 2. 4 is a perfect square. Square root of 4 is 2. So I'll take 2 times 6. So I get 12. And what's left over? Square root of 2. So I need to add this with 12 square root of 2. My perimeter is 26 square root of 2. $23. Take a second and try and do 23 now. On this one, none of the square roots are the same. But I know 3 is a prime and it's down as low as I can go. 75 breaks up into 25 and 3, trying to keep the 3's the same. The square root of 25 is 5. So I have 4 times 5 and the square root of 3. This becomes 20, the square root of 3. Now for 12, this breaks up into 4 and 3. Square root of 4 is 2. So I have 5 times 2, square root of 3, which becomes 10 square root of 3. Well, I need to add these all together. Oh, come on there. My board doesn't want to write. Okay, 10 plus 20 is 30. I have 33 square root of 3. That's your perimeter.